This video is designed to introduce you to the concept of lists. Lists in Python are considered sequence objects, which means they're single variables that have the ability to store multiple values. I'll give you a couple examples to show you why this is useful. So as of right now, our programs are designed to work with the four simple data types that we've covered so far in the semester. We have two numeric data types, so let's say x is equal to 5, that's an integer. Y is equal to 5.5, that would be a float. We also have the ability to store logical values, so z is equal to true or false, that's a Boolean. And let's say q is equal to hello, that would be a string. So those are our four data types that we've studied so far. And that's all well and good, and we could solve many problems using these four data types. But what if I was to give you a problem, say, I want you to store the final grades for 5 students. Okay, not a problem. We could say G1 is equal to 100, G2 is equal to 99, G3 is equal to 75, G4 is whatever, and G5 is equal to, there we go. So that's 5. That was a little cumbersome for me to type in. What if I was to ask you to store the final grades for all of the students in our class, or all the students at NYU? It's going to become time prohibitive for us to go through and create variables for every single one of those instances. So what we can do is we can use a sequence object to make things a bit easier. So I'm going to give you an example of how this would work. So if I want to store 5 grades, I could certainly create 5 variables. But what if I just did this? What if I created a single variable, and I'll call it grades, and inside of that variable, I want to store all 5 of the grades. As of right now, our variables and the data types that we've been studying can only store one value per one variable. But with a sequence object, we can store many values within the same variable. So a list is a sequence object. And a list looks like this. We're going to create a variable called grades. And inside of that variable, we're going to store open bracket, close bracket, like that. The open bracket, close bracket right there denote that we're creating a list. And when you think of a list, you could think of a list like it's a book. So the open bracket and close bracket are kind of like the front and back covers of the book. And we know that inside of a book, we can organize any number of pages. So if you think of a random book on your bookshelf, you're going to have a single book, but that book could have maybe 300, 400 pages inside of that book. And that's exactly how lists work. So I have this variable here called grades. It's a list because we have open bracket, close bracket. And inside of that list, we can use a comma-separated list of values to articulate the values that are stored within that variable. So I'm going to say here 100, 99, 75, 64, and 57. So inside of this list, I am storing 5 integers. There's still only one variable called grades, but inside of that variable, we're storing 5 integers. And we can go ahead and print grades just like we could print any other variable. And we're going to go ahead and run that and see what it looks like. And we could see here that we can print that out and we could see each of those values. So that is the basics of a list, a single identifier that has the ability to store multiple values. So let's go through some of the basics of what you can do with a list. So a list can store any number of values separated as a comma-separated list inside of a series of brackets. Those values could be a mixture of data types. So this is a list of integers, but we could change this. We could make them all floating point numbers if we want, 0.1, 0.7, 0.9, whatever. And that's perfectly valid. The list doesn't discriminate as to what sorts of data types it can store. That's not a problem. We could also mix data types inside of here. Let's give one more grade at the very end. We're going to say very good. Okay, not the most descriptive grade there, but the string very good could also be placed within the mix, and Python really has no problem with you doing that. So we could store any number of values, and those values could be varied in terms of the data types of those values. Now, in terms of lists, we can work with lists in a manner that's fairly similar to the way that strings work. Let's say we have this list. I'm going to just go ahead and erase this. We're going to make a new list. We're going to call this my list, and we're going to set it equal to the numbers 5 and 6. So we have a list. It has 2 elements. Inside of those are 2 integers. And what we can do is, what if we did this? What if we multiply that list by 2? So if you take a string and you multiply a string by an integer, what do you get? You repeat that string that many times. So if I say word is equal to hello times 2, we're going to repeat the string hello 2 times, and word is going to be hello. With a list, it's exactly the same thing. So we're repeating the list 2 times, 5, 6, 2 times, and we print out the resulting list. We will see that the result is going to be the repeated list, so it's going to repeat it 2 times. We're not multiplying each element by the number 2. All we're doing here is we're repeating the elements 2 times, so we're essentially doubling the size of the list. We can also concatenate lists in the same way that we can concatenate strings. I'll give you an example here. We'll call this list 1 is equal to 1, 2, 3, and list 2 is equal to 4, 5, 6. I'm going to say list 3 is equal to list 1 plus list 2. What do you think the result's going to be there? So when you concatenate 2 strings together, you put those 2 strings together and create a compound word. When you concatenate 2 lists together, we would expect to get the same thing. So let's go ahead and print list 3, and we should expect to get a compound list with 6 elements placed together in that order. Now note, the concatenation order matters in the same way that the concatenation order of a string matters. So what if I was to change this to list 2 plus list 1, like that? We go ahead and run this one, we're going to see here that the concatenation happened in reverse. So we concatenated together list 2 before list 1 to create a compound list. Same elements, just the ordering of those elements has changed. One more quick topic with lists. Let's create a brand new list here. Let's call this big list. Inside a big list, we're going to store the strings hello, there, and everyone. So 3 strings inside a big list right here. So remember that we can print out an entire list just by printing big list, right? And that's going to give us the entire list. We're going to be able to see all 3 values. But what if we only wanted to look at the first value, or the second value, or the third value? What we can do is, by just printing out the whole list, we're going to get everything. And if we just want to isolate the list and only extract one of the values, we need to tell the list exactly which value we're interested in. And we could do that using index notation. So index notation works the same way that strings work with index notation. What you do is you type the name of the identifier, in this case big list, and inside of big list, we put the bracket and the close bracket. And inside of that bracket, close bracket, you put an integer value that's going to indicate which item you're looking at. So the first item in the list is always going to be indexed at position 0. So big list at position 0 is going to be the string hello. Big list at position 1 is going to be the string there. And big list at position 2 is going to be the string everyone. Big list at position 3 is going to be an exception because there is no position 3 in the list. Even though there are 3 elements, we always start counting at the number 0. So the highest possible element in this list is going to be big list at position 2. 0, 1, 2 are the valid elements for this list. So if I print out big list at position 0, and we go ahead and run this, we're going to see that we're able to extract out just that first element. Now if you notice over here, as we pulled it out, look at the difference between this line and this line right here. In this line right here, big list at position 0 extracted out the string hello. It's just the string hello. There's no brackets around it. When I printed out the entire list, though, for this previous line over here, we still maintain the bracket and the close bracket around it. So when we use index notation, we're literally going to that position. We're pulling out that data type, and we're not removing it from the list, but we're extracting it from the list so that we can work with it as an independent entity, independent of its list that's organizing it.